Oh no.
Hello and welcome to Apropos, a conversation between Clojure programmers that you can join in live on YouTube. We're going to discuss a few Clojure news items and share our opinions on them. And then we'll jump straight into a REPL and code some exercises or do some demos. If you're joining us live, feel free to comment in the chat and we'll try to address the questions. So today we've got a full panel. Got
Yay!
Mike.
Hello.
We got Mia and others.
Hi, her name is Grace.
Oh. And we have Ray.
Hey. I think Grace is special because she's got a lisp.
Oh, you waited for that one.
Joke.
Snakes.
And
Sorry, go on, yeah.
Eric. Hello. And so why don't we get started today? And hello to all of you out there. You're 14 watching us now. And the millions who will watch us in the future.
Please don't thumbs down us. It really hurts my self-esteem.
I know, especially when you see that million thumbs downs. That really hurts.
Yeah.
Okay, so we have a nice topic for today, don't we? The mysterious GraalVM. How do you pronounce that? That's my first question.
If it was in Dutch, it would be Graal. Graal. GraalVM. Or it would be GraalVM.
Graal.
Oh,
Graal. Yeah. What would you say? I mean, I don't know how else to pronounce it now, actually. What would you say?
Is it named after the Holy Grail? Is that what it means?
Graal. I don't know.
But I would say Graal.
I'm going to say Graal, like that.
Yeah, it's a very cool name.
Yeah.
Like,
So is it like instead of a coffee cup, now it's a grail? All right, so what is this
yes, what is this thing?
VM?
It's made by Oracle, right? And it,
Yeah, we're off to a bad start, but yeah, what's good about it?
Everyone's asking me
Does that
about it.
matter?
I don't know. So many people are like,
Okay.
"Oh, have you done Graal? Can you make a course on Graal?"
Yeah, you've heard about it.
And I'm like, I have no idea what this thing is. It just happened, and I try not to keep on top of these things, you know. So
And-
what's going on?
in some sense, it's a new JVM, right? It's an alternative JVM. And
Is that what it is?
is that it? It's faster, and it's got this polyglot thing going on in it, where you can, I guess, freely interoperate between other languages. All these different languages can be in a JVM together, which we know you can do today anyway, right? But maybe they've made it easier to call between languages.
So it looks like they have an LLVM backend for it. So that means you could compile almost anything to it nowadays. That looks cool. So is it like applying the JIT of the JVM to an LLVM backend? Is that the idea?
I don't know.
Well, someone put this topic in here.
Yeah. So one thing that kind of, I think, got everyone interested was there was a post written that showed that you could compile Clojure down to a native executable using Graal. So that's another thing that it can do.
So is it a VM?
It is
Or
a
is
VM,
it-
but it's also a compiler, evidently. So it's like a mixture of 3 or 4 different things all at once, it appears.
Okay.
And
Okay.
the native executable thing results in these executables that launch instantly. If you look at like a normal Clojure-based JVM program that's a tiny one, that might take like a second to at least launch and get going. Where the native ones are milliseconds or 100 milliseconds to run.
Cool.
And I think if you say, well, does that mean that we can just compile all our Clojure programs down to this native stuff? And I think the answer is no. There are constraints. Like if your Clojure program is doing things like doing reflection then that's not going to fly because
so GraalVM doesn't do the same reflection.
Well, if you're in VM mode, yeah, but if you're like trying to compile down to this native thing, that's where you run into these constraints.
So will it just have an error, or does it just not work? Like, does it know this reflection will not be compiled?
In that post, it shows that the compiler does warn you about things, and it gives you an option of dealing with that, dealing with it up front and just failing the build, or letting it try and fail at runtime if it happens to cross that bit of code.
So there's no it like compiles away any notion of runtime stuff, because it seems like you could just add code to do the reflection at runtime.
Yeah, I agree. Yeah, so there's
because that really changes the semantics of the JVM itself, right? Like the whole object model.
So one thing that's clear that you can't do is eval as well. Like if you try to call something that will generate bytecode, and then you expect that bytecode to be run at runtime, that's not going to work either. Unless you have something, arguably if you put the JVM in there with you, yeah.
Okay.
But if you have
go on, Mike. Yeah.
I was just going to say, if you have a very simple program that's not doing any of those dynamic kind of things, it evidently works. So I think the community is right now exploring, what does this mean, for Clojure? What are the real constraints, and what can you do and what can't you do? I immediately tried to compile the ClojureScript compiler, which is a big Clojure program. And that ran on my box for half a day, and then my box died. So I never found out
oh no!
I never found out if it could work or not.
But I guess ClojureScript itself could run on it, because it has a JavaScript runtime.
So there is, Graal has a evidently new JavaScript runtime as well. It's yet like we have SpiderMonkey and JavaScript Core, Nashorn, all these different JVMs or JavaScript VMs, V8. This one that comes with Graal is a new one. It's derived from Nashorn evidently, and a mixture of V8s in there as well, I guess. But it's fundamentally a new one, and it runs about twice as fast as Nashorn, which Nashorn's extremely slow. So it's about halfway between extremely slow and modern fast ones, But they said they're optimizing it, so who knows? Maybe it'll be extremely fast.
I remember maybe it was a year or two ago that the Microsoft team asked Facebook, or was it? Well, not Facebook. Sorry, the Joint at the time, but now I guess it's the Node.js Foundation, to take a pull request that integrated their JavaScript VM with Node.js as a replacement for V8.
Oh, okay.
And Node.js basically said, "Nah, we're not going to do that. We're not going to touch that."
Oh, really? So Node can have different back-end engines plugged into it somehow, even if Node doesn't want that, or if they're not interested in it. Like you can run Chakra Core, Microsoft's engine, under Node. And it looks like Node, except you have a different engine inside of it. Maybe they've changed their mind since then. Maybe.
No, but I don't think they were saying you couldn't run it. It was just that they weren't going to support it.
Right.
Just one of the things about this open source thing, isn't it? Is that, well, especially with Node, I mean, because some of their library actually talks to EV and this kind of C++ bindings at the lower level of V8. It's not just, there are native libraries as well as pure JavaScript libraries.
Yeah, so I guess anyone can take Node's source code and hack at it and plug in their own engine.
Well, I think that's what the Chakra Core people did. They looked at libuv or whatever it is, libuv. I can't remember which one it is.
Yeah, that one. Yeah.
And they just made that work with Chakra Core. Yeah. But then I think the external libraries that are compiled with GCC or whatever, I don't know if they all work.
So
I guess a decent number must.
Graal does also include a version of Node. It's got a JavaScript engine that you can launch typing JS at the at the command line, but you can launch their version of Node, and it runs their JavaScript engine inside of Node.
Right.
So then you can use things on npm except for those things that have native code, you know, that you know, kind of expect the V8 model, I guess, to be in place. And I guess for those, you have to recompile those native things to get them to work.
Yeah, I guess I'm still trying to understand why would we bother, you know?
Yeah, so why is all this happening?
I mean, I get the point about this kind of like maybe compiling might go a little bit faster in some situations, but you've got a lot of constraints around it. It may or may not work with this facility, that facility. It just seems like you're buying yourself a jail for some type of jail. So it better be, you know, if it's not a jail, it better be a nice hotel, you know? I don't know what you know what I mean?
So one thing I saw,
you
which
better
actually
get room service or something.
Yeah.
You know?
So there's an interesting talk by an engineer from Twitter, and he gets, I guess, really deep into the JVM workings to make things work fast at Twitter, and even so far as like looking at the optimizer inside the JVM. And his assertion was that the Java optimizer has kind of reached a point where it's stalled in terms of development, in the sense that it's becoming difficult to make further improvements without breaking other things in it. You know, it's reached this point where it's hard to do. And he said it's been this way for like a couple of years now.
And so this is kind of a new direction that they think will be faster eventually.
It actually, so it's a new direction in the sense that I guess it's cleaner and more modularized. So the optimizer and the code base internally is easier to understand, and you know, like as a human developer, you can grok it now. You can actually get in there and you can make a change without, and it is faster. Like the Twitter, they were doing comparisons, and it's about 10% faster than the regular JVM code, which is, you know, worth millions of dollars to them.
But is this the code where they compile away the runtime semantics?
No, this is just regular JVM type usage.
Java. Okay.
And I guess at the core of what's going on there, and he was explaining that it has better escape analysis. So I think it puts less things in the heap, does the right thing, you know, in terms of escape analysis.
Mm-hmm.
And a part of this Grrrl thing is, I guess, that Oracle has this half commercial, half open source model. And if you buy into the commercial thing, then that one's like 20% faster. So if you have money and you want to pay for it, then you can make your stuff go even faster.
I was trying to figure out. I'm sorry, keep going.
Oh, I was just going to say, like, you could, you know, if you're Twitter, that 20% is going to be worth, you know, 20 million to you in terms of server farm stuff, then you'll just pay for it.
Well, but Twitter doesn't ever have to make any money, so
I guess they could avoid spending it.
Doesn't seem to be their objective at the moment.
No,
that is
they're like
really
Tesla,
cool.
just burn through money.
That's amazing that it's that much faster. I was trying to remember because I knew that I had heard about GraalVM like a million years ago at ClojureConf, and I couldn't remember why. And it was Karen Meyer.
Oh, okay.
She was doing interop between. She's got this blog post from October. Interop between Clojure R and Python with GraalVM. And so she's got because I guess that the GraalVM uses this AST called Truffle, and we don't have Truffle Clojure, but there is Truffle R and Truffle Ruby, and a bunch of other things. And she actually gets R working in Clojure, just like embedded interop in the blog. It's very interesting.
That's cool.
I can't actually comment on YouTube.
Borrow all of R's libraries.
Yeah,
and you can also do that from the JavaScript side. So you can, from ClojureScript, you can make calls into R from JavaScript essentially, and Ruby.
So
it's really weird.
Yeah, it seems like it opens up a ton of libraries that you wouldn't have thought possible, or like would have thought of using, I guess, without a lot of work. Yeah,
the flexibility aspect is kind of nice, right? Like if you have a team that has, like, you're doing stuff in Clojure, but you have machine learning people who know Python, and you just want it all to run together and be happy.
Yeah.
You could just interrupt between all these languages.
The original dream of Unix.
That's the holy grail.
Yeah, but I think sometimes the operational aspects maybe do, like you said about Twitter and stuff. Maybe the operational aspects dominate this bit of thinking, which is not very interesting to me, to be honest. I think it's more. It's interesting if it opens up a field of saying, "Oh, right, now we can use all this machine learning stuff from Python in Clojure."
Yeah, that'd be cool.
That gives you quite a big reach, doesn't it? That's what Karen Meyer's interested, I guess, in, is it, Maya?
Yeah, more or less. Yes, she's doing all that machine learning stuff. So.
Yeah, so like if you were writing a program and there was some solution already in R or something like that, that would be nice just to use it, right?
Yeah.
And that's you can kind of do that today though, right? You have JVM-based languages and you just kind of use them.
I mean, that's
together.
one of the big advantages of Clojure was being able to take the JVM libraries already. And now I see Clojure is losing one of its big advantages because now they're all able to use all of each other's libraries.
But they're not Lisp, so
that's true.
Well, because Java could already do that. Yeah.
So I don't know what Graal did to make it.
I wonder who has the biggest advantage here, because it looks like the languages with the fewest number of native libraries can now have a bigger advantage than the ones with a lot of native libraries, right? And so Clojure might be the winner in that case.
And we can all stop writing things in Clojure and write everything in Python instead.
Is that a joke?
Yes.
I hope that's a joke.
I love very strict controls on white space. It's just my favorite thing.
Yeah.
But it's also
difficult to really get excited about it, to be totally honest.
I'm not excited about it either.
So, all right, I'll try to convince you of one thing.
Okay.
It's something new that's happening in the JVM world. I mean, if you want to just say that you're happy with the JVM as it is today, then that's cool. I'm happy with it. We have Clojure and it runs on the JVM. And
does it have tail call elimination for the JVM stuff?
Oh, that would make me happy. Yeah, I haven't heard of that.
I mean, there's this whole compiler thing which sounds iffy, and then there's the multi-language aspect, which sounds kind of cool, actually.
Yeah, it's like you have to see that actually occur before you're convinced that one's going to mean anything.
Yeah. The funny thing about it to me is that Java, the direction of Java seems to be going kind of the other way to this. This seems like, a plumping out of the JVM into like more and more of these environments. Whereas the sort of Java, the JDK direction seems to have been to get like Project Jigsaw and stuff like that. All seem to be aimed about getting the whole runtime for the Java virtual machine to be smaller and smaller and smaller, so that the startup can be faster, so you can ship less code around. So it seems like they're heading in two different directions a little bit here. I mean, not that it's necessarily incompatible. They're
also borrowing from each other too. Like the Graal compiler or optimizer, I think, is in Java 10. It's just it's a hidden or whatever, like one of those XX features that you have to enable.
It's an Easter egg.
Yeah.
This is weird.
Yeah. So it's like, it makes you hard. It's difficult to assess. What does this really mean?
Yeah. Because in theory, you should be able to thin out the libraries and that's what Mark Reynolds said, the chief Java guy, a couple of years ago, was his ambition was to, in Java 10, Java 11, Java 12, to focus on thinning out the shippable quantity of bytes with the JVM.
Well, they might be doing that with the Graal thing to get more, I don't know, performance out of each byte. But I mean, I think it would be cool if we finally had this like cross language sharing, like true cross language sharing, we could finally just use the best tool for the job.
Mm-hmm.
Is that possible? Where you could just say, like, oh, Python has this library and Java has this library, and here's some C++ stuff that somebody wrote, and let me tie it all together. Obviously with Clojure, because it's the only language that might actually let you do all that. In a reasonable way, I mean. Is that what the name is referring to? It's the Holy Grail.
I think so. Yeah. I'm speculating, but I think that's true.
You're still gonna have tons of interop issues, right? Because every language has like different number semantics, and
maybe that's what they did, was tried to smooth some of that over. Maybe if you say, what are they really doing that's different?
Right. What is a Python array versus a Java array? And yeah.
So someone in the comments suggested that it's got faster startup time. And this is one of the things that I was wondering about, and it came up in the Google groups as well, which is like one of the biggest complaints people have when they're switching to Clojure is startup time.
Mm-hmm.
And I'm wondering if it's actually faster, how much faster it is.
Well, if you compile it, so what I've seen is that if you do the compilation, that Clojure starts up much faster because it basically saves the image. It doesn't have to run the code that generates all the vars and all the strings and all that. It's just already in memory. So it's just as fast as you can read the memory.
It seems to me, though, that's kind of something that Mike was talking about a few weeks ago. That's something that we could do anyway.
Yes, we could do that.
Just by caching stuff. We've seen these bytes before. Fine.
Lazy load stuff.
First time around, it's a bit slow, but after that, boom.
Yeah, I guess you can now, if you have a small Clojure thing that you want to have like a little command line app out of it, you can now make one. I wonder if you could before, but now you can.
Yeah.
Like
well, I mean,
right.
Go on, Mike.
And one that can run in like 100 milliseconds, which is what you typically expect.
That's cool. That's significant. Yeah. That's really nice. And does it target different platforms? So I could write it in Clojure and it'll output a Windows binary and a Mac binary and that kind of thing.
Don't know. I know Graal is only available for Linux and Mac OS right now. I think they said Windows will come in the future.
Don't they all say that?
Yeah. Windows doesn't get any love. Yeah. There's also now a Graal channel in the Clojurians thing, and people are starting to chat about it there. And some of the things that I find exciting are like there's been some optimizations that make Scala itself run faster. And Alex Miller took a look at the paper and he's like, maybe that applies to Clojure as well. Like those optimizations may be really cool. Unless that doesn't excite you, but I think if all the stuff could run faster, then that'd be nice.
Well, weren't there certain things in 1.8 of Java, like the function references and stuff like that, which in theory should have made Clojure faster, but we didn't take advantage of them?
Oh, what's that? The dynamic stuff.
Yeah.
Dynamo. Yeah.
Yeah, but because I think it was, it might break compatibility with 1.2 or whatever. Yeah.
Right. Like I think that the goals of Clojure are to stay compatible with Java back to 1.7, I think, if I remember correctly.
Yeah. So,
Yeah. We won't see the benefits for a while.
So I'm just saying, some of these, if some of these advantages are quite transparent, some of these engineering efforts are transparent, then maybe we'll get the benefit. But if you have to change the internals of Clojure, maybe not.
Ray, would you be happy if it were being hosted by a company other than Oracle? And because now you're in a position now where companies may start paying for this commercial variant of it. That might be nice, if you have like lots of money being dumped into this technology, then the free side benefits from it as well. But
yeah, I mean, I don't know. I think, to be totally honest, I kind of don't think of Oracle as an engineering company.
Yeah.
I I think that the people they've got here are from Sun, or from that Hangover group, the research group they have at Sun Labs. And that group was a bit like Google in the sense that they just did things for fun, and they did things for research purposes. And they had Guy Steele there, and they had all these kind of fancy people there who were basically, thinking about the good of the world, And it seems like Oracle's a bit less like that than Google is, or even Microsoft these days. So I don't know. I'm not a fan of Oracle. I'll put it out there, but at the end of the day, if it's great for the VM and it's great for Clojure, I'll take it. But I don't have to cheer up. I'm not gonna be out on the streets and with the bunting saying "Woohoo!" on Oracle awesome, because I don't think.
Yeah, this evidently came out of Oracle Labs, which is in Europe. Maybe that's a different thing. Maybe it's
Maybe
like not really
company.
Oracle proper. Yeah.
Yeah, I mean, it's confusing to me because, like, I don't feel that excited about it, but I don't think I would feel excited if the JVM found some big improvement either. If they're like, hey, we're 10% faster, I'd be like, okay, great. I hope to see that benefit, but I'm not gonna talk about it, or I don't know.
Yeah.
I don't know. I think I'm also kind of like I still remember the days when I thought I would be like a compiler writer. And the fact that the JVM costs billions of dollars, like, to me is kind of like, it's not interesting. Like, I'm never going to do something like that. I'd rather have little techniques that I could, like, what is it? Like, I want to be able to build it myself. That's the kind of stuff that I get interested in. Like this idea that you could get 80% of the benefit with just this one little technique that they've discovered.
Yeah. I'm a little bit excited about it. It feels like maybe Java has some more life left in it. Like there's at least some activity going on there. You guys don't seem to be that excited about that. Yeah.
Well,
Java works, it's fine, right?
Yeah, it's a bit like getting excited. Like if you're a C programmer, getting excited about, I don't know, GCC or assembly programming, or the assembler, because it all goes down to that level, to that thing. But do we really see it? Do we really care?
Who really cares about like what processors are coming out next year? I mean, right. I know a lot of people do, but I don't. I don't buy a computer every year. I don't keep track of that. I just buy the.
It gets tiring.
Buy whatever's on the shelf the year I need one.
Yeah, well, you're not mining Bitcoin, so
I know that's true.
Worry about it, Then you run.
If this runs the Bitcoin mining rigs 20% faster,
maybe
paying for the commercial license.
I don't think many Bitcoin rigs are running Java, though. In fairness,
But now,
no, they could. Yeah. Oh my god. Yeah. On that note, on that bombshell.
20% faster is cool. Like if a company like Google that uses a lot of Java and uses a lot of electricity,
right,
they're 20% more efficient. That is awesome. Right?
Yeah, definitely.
For us, it's going to be more like the polyglot stuff and
the new blog, the ecological case for GraalVM.
Yeah. They're just going to run 200% more stuff is what they're going to do.
Yeah, more ads.
Yeah. Ads delivered 20% faster.
Because our users have told us that's what they're like. I mean, come on, Zuckerberg. Your users haven't told you shit, Anyway.
Oh, wow.
No, they've told him everything.
Oh yeah.
I don't think anyone knows as much about me as Mark Zuckerberg does.
I don't have a Facebook account.
We just haven't. We haven't told him anything on purpose. Is I think the thing.
Yeah, that's true. He made it in his dorm room now, so it's good.
It's PHP, and PHP 7 is more efficient than PHP 5.
20%.
So,
What I want to know is when are we going to be able to do PHP interop with the GraalVM?
Ooh, I think you're trying.
Oh, that's on their slides, right? I thought I saw a little PHP
troll
thing.
face.
Polyglot reference. Yeah.
I think this is our most popular episode yet. 24 people care about the GraalVM.
No, but no one's talking.
Yeah, they're all quiet because they're all just like, what the fuck are these idiots talking about? This has got absolutely nothing to do with Clojure, by the way.
I don't know.
But okay.
I am
almost nothing. Yeah.
That's true.
I'm way too young to know most of this.
Yeah. The snake has been more entertaining than GraalVM, that's for sure. Yeah.
She's so cute. I just love her so much.
Is that like the Python in the show? God almighty. I'm really struggling now. Yeah. She's lovely, yeah. She's lovely. And I'd rather talk about her than GraalVM. Yeah. Well, Mike, you want to do a demo of the GraalVM, don't you, Mike?
No, I don't.
Do some kind of
complete it. Come on.
You got to do the metaphor of the Ouroboros and the tail recursion.
Well, no. Someone needs a Python. Like, this is not a Python, and I think that's the problem here. There's no Python interop with a snake.
Yeah, that's probably the equivalent of Python 3, isn't it? Yeah.
Well, she's a Western hognose snake. Do you see? If you see her little nose is it's got a little shovel on it.
Wow,
they're burrowers.
That's cute.
She's not going to suddenly bite you.
No. Well, they don't really have teeth very much. Like, they have teeth, but they're way in the back. They're rear fang snakes because they eat amphibians, which don't have teeth. So if she does bite me, it's because she thinks I'm food. And then she's actually got a little bit of venom, but it's like a bee sting.
Oh, okay.
Gotcha.
We have someone in the chat who says they've been using Clojure for the last 7 or 8 years, but they want our point of view for why Clojure Lisp is worth it to learn.
They've been using it longer than me.
Yeah.
Likewise, yeah.
They must have their own opinion at this point because they're still so they want our yeah. Okay.
I mean, I've been programming for 2 years.
Yeah. I think Clojure is worth learning because if nothing else, it teaches you about a style of programming that is different to object orientation. It teaches you about functional programming. It teaches you about immutability and about a Lisp. So I think it's like there's so many things that are like to some extent out of the mainstream that it's interesting in itself academically, but also, as it turns out, you can really use it in production systems as well. So I think there are many, many advantages and wins to it. Otherwise, what am I doing here?
Why are you on this?
Yeah,
that's a really good answer, Ray. I really like that.
Yay! Thank you, mate. Yeah. Feel free to use it.
So, I think to me, like I was using Common Lisp before Clojure, and I really felt like when I was programming in Common Lisp, there was a lot of like wisdom like baked into the language and the libraries, more so than the Java libraries that I was used to using. It just seemed like there were a lot of smart people who put time and effort into this. You know, Common Lisp was a merging of several different commercial and academic Lisps into one. And so each of them was a separate branch of this big tree of smart people developing from scratch their own Lisp. And so there was a lot of like writing and rewriting of Lisps. And so I think that churn helped keep the good ideas going. And then when they merged together, you had merging of all the best of all of them.
Like a distillation of the good ideas.
Yeah, exactly. And so then when Clojure came out and I started using it, I felt like a lot of the good stuff was distilled out of Lisp. And so all the old flaky stuff that like had to be there for backwards compatibility. That all got distilled out, got distilled in with more functional programming stuff. It had the immutable data structures. So I'm sure not everything that was like great about Common Lisp made it into Clojure, but it definitely feels like it's got that lineage of wisdom that you don't see in a Java or a C++.
I think that's a great point, and honestly, it really is a great point, because it was one of the first ever programming languages, Lisp, and it's still here, and nothing else has survived it, has it? From the 60s?
Fortran is still around.
No one's getting excited about Fortran, though, are they? They're kind of
right, and it's designed by committee, right? The Common Lisp was designed by a committee, but from parts that were not committee designed. Yeah. And you imagine someone at MIT, they graduate with their PhD and they move to a postdoc program at Stanford, right? And they're like, you don't have a Lisp? Well, I'll make one, right? And so then they make one and they experiment with stuff. And so they share with what people did at MIT, but they started over. They tried a new thing, a new way of compiling it, building new machines that will run it faster. And it's just that I think that writing and rewriting and iterating on it, that doesn't happen because they didn't have to have backwards compatibility back then.
They could also write programs to upgrade their old programs, right? Like since Lisp is so easy to manipulate.
That's true. That's true. And it was, a small number of users, and, the programs didn't have to run forever like they do now. There's a lot of reasons why they didn't need backwards compatibility. But languages that people use a lot today, they're often like the mistakes are what get carried forward, right? like JavaScript was designed in like 10 days as the legend goes. And so like everything that they did is now still in there, and all the problems were there from the beginning. And this is sort of the opposite. It's like designed over 50 years, right? And so you have, if they probably tried all these things that are mistakes now in JavaScript, and they decided, no, let's not keep them.
Yeah. Like if we decide the same thing about core async, we could check it out, right? Because it's just a library. It's an experiment in some sense, And
Clojure is really, it's exciting. Like, especially, when I started programming 2 years ago. So by that point, all of the focus was on web apps, getting focused on mobile apps, really this full stack thing. Like, what does full stack look like? And with Clojure, you can write these really expressive programs that do a lot with not very much lines of code. They're easy to read, and you can do full stack Clojure. Being able to write something with a Clojure backend, a ClojureScript front end, and have all those pieces work together really well. And ClojureScript is just such a gorgeous way to do React. Like, React is the best thing to come out of JavaScript, and ClojureScript is the best version of React. When people ask me, like, why should I learn Clojure? I'm like, you should write Clojure because you can write ClojureScript. You can do these beautiful web apps, and you can do them quickly. So, because Lisps are so good.
Yeah, it's really weird because, so I remember a few years ago I gave a tutorial on ClojureScript, and one of my old professors from school was there in the audience, and he asked, why would anyone want to compile a language to JavaScript, right? It's like, obvious. I mean, he was an industrial program, so he does not, he does have this academic view on stuff, but it's like to be in the browser, right? But like to him, like the language is not important. It's all about like where it's run, and like you're not like, I mean, theoretically it's true. You're not gaining anything because you're still Turing complete and you're compiling down to the language. So it's like a double proof that you're not gaining anything. But there's just all languages that are Turing complete, like the difference is expressivity. What can you do? How easy is it to write bad code in it?
I mean, that's the question. Like, the question isn't why would anyone want to compile to JavaScript? It's why would anyone want to write JavaScript if you don't have to?
Exactly.
Well, bizarrely, I was watching the SICP things again recently, just for fun. I'm a sick individual.
Oh, those are awesome.
Yeah, and they start talking about like what should your language have, you know, and you know, things like having the ability to extend the language, to have means of like, abstraction. All these kind of things are very difficult to find in languages other than a Lisp. And they kind of knew it; they were setting it up like that. But still, you know, once you kind of have that model of what it means to write in a language, what that language offers you, it's very hard to kind of throw it in the bin, to forget it.
Sometimes I talk to my kids about this language, and I talk about like redefining addition, and they don't think there's anything weird about that. I'm like, come on, I just redefined addition. You can't normally do that, you know? So it's like, it's such a flexible language that even children just expect it. Like, yeah, of course you could do that, right?
But isn't that just like programmers have a Stockholm syndrome, basically, you know, where everything is like, you know, you've been taught that everything is going to break all the time. So, you know, you're always treading on eggshells, you're always walking on glass, you know, and, you know, you don't have to do that so much with Clojure. It just doesn't feel as delicate, as brittle, as, it's kind of like dangerous.
It's
Some people love that kind of stuff, you know.
But people aren't used to working with well-designed languages. They're used to languages that have so many sharp edges all over the place. The Javas, the JavaScripts, and like programming knowledge is all about like remembering, like never use that in this use case, or I mean, even stuff like in Python, if you do, if you have a dictionary and you want to get a key out or a value out for a given key, if it doesn't have the key, like it throws an error. And so you just have to know that. I mean, that's fine. It's fine semantically, but like it just doesn't compose as well as the alternative, which is have return none or null or whatever it's called in your language. And it's just, I think it's just the wrong decision. It means you have to have an if statement before you take anything out of a map you're not sure about.
Yeah.
And now you're just putting ifs everywhere again instead of thinking on a higher level.
Or of course, people write a library that a certain subset of the community will use because they're aware of this problem. And then you've got fragmentation and a lack of idiosyncrasy around the language. Because that's what happens with JavaScript, is that people see all the sharp edges and they write all these libraries to take the sharp edges off. And then some people use less, some people use underscore, some people use Lodash, you know, and then there's a sort of fragmentation in the solution space for this kind of stuff, which is, you know, like innovative, creative, all that kind of dynamic good stuff. But basically it's just pointing at the fundamental flaws. That's why there's, you know, there isn't so much churn in JavaScript because everyone's got great bloody ideas. That's not where all the great programmers live. I'm sorry, but it isn't. It's where all the sharp edges are. You know, so there's lots of effort, engineering effort, put into reducing the number of sharp edges, number of kind of things you can trap yourself with and hurt yourself with.
There's also a distrust of abstraction.
Yeah.
So like people just look at, is it high level of abstraction or low level? Not the quality of the abstraction, not like whether it's useful or anything like that. It's just how high or how low. That's the only thing they see. And they distrust anything too high, and like too low is too cumbersome. So they try to find something in the middle. And they just, I mean, I seriously think this is it. They just haven't experienced good abstraction before. They haven't experienced what it's like when stuff starts to align and it makes sense that like you know what code to write because it's the only code that would make sense for this case. Like, I mean, it's one of the nice things about Haskell is that happens, I think, a little bit more, that you get like I need to call this function. Here are the 4 things it needs. I know their types, and I actually have those 4 things. I just have to put them in the right order, and I can call this function. And it happens a lot in Clojure too, where it's just obvious that these are the 3 things I need. Let me just call this function on.
So we've got another question. We're having a discussion topic today. Okay, what the hell? Doesn't matter. It's fine. So we have another question from Gamer Girl Diantha saying, hello, I want your opinion about CLJS React Native environment.
I like it. I think it's the best way to develop mobile apps.
It is very nice.
It's nice for the main reason it's nice is that you get super fast feedback. And mobile apps are, even more than web apps, like very much about design, because you're such a constrained system. You have to iterate really quickly on different designs, and having to recompile to like see what it looks like, and having to like tap through each time to figure out like, how do I get to this screen again so I can see what it looks like? All of that gets taken right out. You can have your iOS simulator on this side and your Emacs or whatever you use on this side, and you're typing and you just see the UI changing as you type, and there's nothing else like that. Even React Native with JavaScript does not get there.
Yeah, I think the idiomatic feedback loop in Clojure is part of the strength of the language and environments. And we're always looking for that, aren't we? You know?
Yes, that's what we seek out. And there's no better tooling or community around that for feedback. That's probably what Clojure does best.
Yeah, I'm still a bit surprised that is not touted as the killer feature.
Yeah.
You know, because there's a lot of Me Too features, but this is a killer feature. Yeah.
Well, I think it's, again, people haven't experienced it. So like in JavaScript, they often, and like in React, they claim they have it, but then I don't know, I've heard it takes weeks to set up, and then you have to, it breaks all the time, and so you can get into a little mini flow, but then you
lose it again.
It goes away. Yeah.
But also you're buying into a bunch of stuff which again is not idiosyncratic to the platform. You know, immutable JS and Redux and all these things. I mean, React is itself a kind of gets a lot of pushback from the JavaScript purists who say, oh, you know, that's not how we do it.
How do you be a JavaScript purist? What's wrong with you?
I used to work with people that wrote their own version of jQuery. And
they had a non-invented here syndrome about
massively, yeah. And they kept that going in an enterprise environment, by the way, for a commercial website.
Wow.
For 10 fucking years, you know. And eventually we managed to get the damn thing out and replaced with jQuery, you know, just as jQuery was coming to an end. But still, you know, the point is you have a whole ecosystem out there with the jQuery world that we just couldn't take advantage of because of this one guy was like, yeah, but I know JavaScript really well and I can do it faster. I can do all of the functions that you're interested in JavaScript. I can do it faster. jQuery is too slow. And it's got this global namespace.
Was the one who wrote JavaScript.
I mean, also like the whole cross-browser testing thing that they had set up. Man. Like, there's no way you could replicate that.
Well, you know, I think he was obviously a good guy. You know, he knew what he was doing, and he had like a good understanding of the DOM across different browsers and good understanding of how to optimize JavaScript. And those people have a place, but to me, they're not in commercial settings. You know.
Well, there's a place for that too, for that kind of non-invented here, because like Lodash is now the standard, but it just re-implemented underscore, which was the standard before, and so and everyone thinks it's better now. So
yeah. Well, I think there's a I'm not saying there isn't a place for hardcore engineering. I'm just like this not invented here syndrome. That's you know, there's always a place for hardcore engineering. You know, you want good engineers in your environment, that's for sure. But you don't want people who can't leverage the stuff that's out there that's good enough, you know? Or you want them to be really, really clear about what is not good enough about this stuff. Anyway, to answer her question about ClojureScript and React Native, what about the smallness of the ClojureScript community in that space? I mean, Natal seems to be kept well maintained, but there doesn't seem to be that many like great examples of it working.
Yeah, it doesn't seem like there's as much adoption yet of it.
Is there a lot of adoption of React Native in the JavaScript world? I mean, a lot, question, yes, because probably JavaScript is gigantic. But
yeah,
I mean,
like what's a lot?
Yeah,
but it is true, like what Ray mentioned. Like if something's broken for you with ClojureScript and React Native, the community is a little bit too small still. Like the answers are out there, and you can find the people to help you, and you know. But it would be nice if that were a larger community and you know a larger collection of answers and more people contributing to smooth out the rough edges and stuff like that. So there's a somewhat of a problem in the smallness of that community still.
I'm not saying we shouldn't do it and we shouldn't experiment with it. I'm just saying that, you know, in terms of like when is that pond for everyone? You know, it's probably not quite yet. You think you probably have to you have to kind of be ready to sit on the leading edge of something to get there, I think.
And I mean, to be honest, I did a consulting gig in React Native with JavaScript a couple of years ago, and it was still very bleeding edge. Stuff was breaking every time we would do a minor upgrade, and I'm sure it's much better now, but you know, it's not like it's stable in JavaScript, and we're just not taking advantage of it. I think there's still a lot of churn there.
Yeah, that's surprising to me that like a new version of React Native would come out and just break things so flippantly. But they do. It's a fact. It makes me feel like if you're going to do a project and it's going to last for a few months, just stick with that version that you started with and don't ever upgrade.
JavaScript community, they upgrade everything they like new tools and everything every time.
I mean, and part of it is it's the language of choice for like when you're trying to get a startup off the ground very quickly. Like there's the startup ecosystem isn't something that I think we talk about a lot in computer science, but it is like, you know, I'm living out here, like this is what I see. Most of the jobs in computer science right now, right? Most of the software engineering jobs are for equity writing JavaScript.
Oh wow.
And if it's going to be a mobile app, then the stack is Node and React Native. But a lot of these are very small. Usually they've only got 1 or 2 engineers on staff. And there's not really a way to measure the size of that community or the amount of expertise that's contained in it. So, and React Native, it's really cool. Like I love React so much. And I wish that React Native I wish that the ClojureScript had been stable when I was working in it, because I bet it's fantastic.
Well, I think there's no doubt that Facebook is still investing in it and it's going forward. But I think, for instance, if you look at, really it's targeting 2 platforms, isn't it? iPhone and Android. And the iPhone support seems to be a lot better than the Android support. You know, it took about a year for the Android stuff to come out, so that still feels a bit like a second-class citizen. Also,
we did do this was a couple years ago. We did iOS and Android, same code base. There was just a little bit of native stuff that we had to do that was not available yet. So we did have to write some Objective-C and some Java. But it was, I felt like it was the best way to develop for both at the same time. The apps worked exactly the same.
I've got to go. It's 1. We forgot to do the REPL.
We could just forget about it today.
Well, they
Yeah,
asked
we'll do
us.
it
They
next
asked us what was good about Clojure, and this is overwhelmingly what's good about Clojure podcast. So
Yeah, I think we spent too long time not talking about Clojure. So it's
The Grrrr stuff. Yeah.
we could have just talked about the snake for
yeah,
GracVM. GracVM is coming.
yeah, brilliant. I think we should wrap it up then. Yeah.
Yeah, let's wrap it up. So what do we have to do? Please, everyone, subscribe, thumbs up. Like.
Come back. We'll do the REPL next week.
Yeah.
Yes. We will. We usually do a REPL if this is your first time. We usually jump into a REPL that we can all share and we do some exercises and stuff. But we got carried away with the talking and so answering questions. So thumbs up, subscribe, share it with your friends, retweet, +1, like, heart, star, all the click the icons, all of them.
This is getting weird.
It's a kind of bully, you know.
All right. Bye, team.
Bye.
Later on.